This video is going to cover limiting reactants. We will look at a few particle diagrams like the one that you see here, and we'll also walk through a few practice problems on your notes. So whenever we're looking at limiting reactants, we always have to have a balanced equation. So to balance this first equation, all I need to do is put a 2 on the product side, and that will make sure that my hydrogens and chlorines are balanced. So remember, this is just a ratio. It just means that for every 1 hydrogen molecule and 1 chlorine molecule, I can make 2 HCl's. So if I take a look at my drawing down here, one way to kind of think about it is that I can group these together. So there's 1 hydrogen and 1 chlorine, and I know that every time I do that, I'm going to make these 2 HCl molecules. And I can kind of keep going through. I can group another hydrogen and chlorine molecule, and I will make 2 more HCl's. And then I can do that again. There's my 2 other HCl's, and then I can do that one last time right here and right here. And so as you can see, I'm left with these 2 hydrogen molecules here. So what I've run out of is the chlorine, the green molecules. So that means that this chlorine is really my limiting reactant because it's limiting how many more HCl products I can make. So you can see over here, I've included these 2 extra hydrogen molecules in my final drawing because remember, they don't disappear. They are still there, but they're just there in excess. So we would say this hydrogen is my excess reactant. So we're gonna look at a few different practice problems here. For this first one, I've balanced our equation already. We're not gonna walk through that part together. But if you'd like to try to balance it on your own, that's totally fine. To get started on these equations, we want to pay attention to the fact that we're given our 2 different starting amounts. So we looked at this a little bit already on how we can use our mole ratio to set up our problems. So because I'm given 2 different starting amounts, I have to set up my 2 problems. So I'm going to write down my startings in both of these spots, and then I'm going to follow the same steps. If I know I have moles and I want to find my product, I can just use my mole ratios to go from what I have to what I want. So if I have moles of magnesium on the top, I know I have to put magnesium on the bottom, and I know that I'm going to get my ratio by looking at my balanced equation. So there's 2 magnesiums for every 2 magnesium oxides. So if I multiply and divide those, I end up with 3 moles of magnesium oxide. I can do the same thing for oxygen. If I have oxygen on the top, I know I need oxygen on the bottom, but this time I can see that there's really just 1 oxygen for every 2 magnesium oxides. So the top part's going to stay the same. So this leaves me with 8 moles of magnesium oxide. Now I can look at this problem and I can tell right away that this is my smallest amount. So that's how I know what my limiting reactant is. Okay, so my limiting reactant is going to be magnesium because it produces the smallest amount of product. My excess reactant is oxygen. So the number that I really care about is this 3 moles right here. This is telling me how many moles of my product I can make. So when the question asks me for theoretical yield down here, remember theoretical yield is always, most of the time, talking about grams. So if I know moles, then it's pretty easy to convert moles into grams. The only thing I have to do is I'll just set up my train tracks. And if I have moles of magnesium on the top, I know I'm going to put moles of magnesium oxide on the bottom. And then I just have to find my molar mass. So I can add up a magnesium and an oxygen in my calculator, and I come up with 40.309 grams. And now I can multiply the top numbers, and that gives me, we'll say 120.9 grams. So this is my theoretical yield. So I did the same types of calculations that we've been talking about. We know that if whatever we have, especially if we're talking about moles, to try to get to what we want, we're always going to use the ratio for my balanced equation. So that's where these numbers all came from, was from my balanced equation. The last step was, I know that if it asks me for theoretical yield, I just have to turn it to grams. So I don't really care about this number 8. All that's telling me is that it's going to make too many. I don't have enough to actually make 8. I ran out of magnesiums when I got to 3 moles. The last part of the question asks us to find our percent yield. So percent yield is a formula, and you can find this formula on your purple sheet. I like to remember it as A over T, or AT. So that's the actual amount that's produced divided by the theoretical amount. So for this problem, it tells us that 113.5 grams were actually produced. So that's going to go in the A spot. And then my theoretical amount is that 120.9. And then just remember, anytime I'm talking about percent, I know I always have to multiply my final answer by 100. So when I plug this in my calculator, I come up with 93.9%. Which isn't too bad. Okay, it's kind of like when we looked at the graham crackers and the s'mores, right? If you started out with enough graham crackers to make 4 s'mores, if I started dropping some on the floor, that means I don't have as many graham crackers, so I can't make as many s'mores as I thought I could. So your theoretical yield is kind of like, how much should I be able to make? But the actual amount, actual yield, is what you actually made in the lab, because we know that there's always going to be some human error. All right, let's look at number 2. We're using the same formula, or the same balanced equation, so the same steps, except for this time we're giving grams to start. So we know that if we're in moles, we can use our mole ratio, but if I don't have moles, then that means I need to convert to moles. So this is going to be 3 steps. So we're just adding this one step at the beginning because we're starting with grams. So if I have 15.9 grams of magnesium and then 12.8 grams of oxygen, I know that if I have grams on top, I have to have grams on the bottom. So my first step is just going to be to convert from grams to moles. So I'm going to look at my periodic table. I'm going to get my molar mass, and I'm going to plug that in for my grams. I'm going to do the same thing for the oxygen. I have to go from moles to grams, and this time I know that since I have 2 oxygens, I have to take the 15.999 and multiply it by 2. So I get 31.998 grams. So now that I'm in moles, now I'm doing the exact same thing that I did in the last problem. I'm going to use my mole ratios to help me convert to the moles of what I want. So if I have magnesium on the top, that means I have to put magnesium on the bottom. And then I'm going to put the magnesium oxide on the top because that's what I'm looking for. And now I'm just going to pull my numbers from my balanced equation. So I have 2 magnesium for every 2 magnesium oxide. I'm going to do the same thing for the oxygen. Oxygen goes on the bottom. There's just 1 of those for every 2 magnesium oxides. So we're still just using that balanced equation, our mole ratio. From here, everything's the same. We're multiplying the top, and then we're dividing by the bottom to get our final answer. So we're still in moles, right? I've just first converted my grams to moles, and then I use my mole ratio to convert to moles of what I want. And this comes out to be right at 0.8. So now, in order to answer my question for what is my limiting reactant, right, I'm just looking to see what produced the smallest amount. And so since this is the smallest amount, that means my limiting reactant is magnesium. My excess is going to be oxygen. And now if I want to find theoretical yield, remember that just means grams. So I know that I can make 0.654 moles. So now all I have to do is convert that into grams. And I can go from moles to grams using my molar mass. Then I can multiply the top. And I get 26.4 grams. So that is my theoretical yield. It's asking us again to find percent yield. And again, percent yield, I just remember at A over T. That's my actual, which was given to me in the problem right here. 21.75 grams were actually produced. My theoretical amount is the 26.4. And then remember, I just have to multiply that by 100 at the end because I'm talking about percent. So I get something like 82.4%, which isn't too bad. So at this point, most of everything we've talked about is the same. We're still using our mole ratio to go from moles of what we have to moles of what we want. Sometimes we just have to be able to convert to grams at the beginning or at the end. I know that it's my limiting reactant because it's producing the smallest amount of my product. We're going to look at one more. We're going to skip to number 4 because again, this is the one that goes from grams to grams. So we're going to do another one like this. So I have the two things that I'm starting with. I'm setting up my equation. And I know since I'm starting with grams, I have one extra step because my first step is going to be to convert to moles. So I'm starting by writing down my two starting amounts. And then I'm just going to follow my units and follow my steps. If I'm starting with grams, I know that grams has to go on the bottom, and I have to convert that into moles. And again, we can just use our card that has the setup directions to help us with each step. I know I'm going to get grams from looking at molar mass, so I can plug that into my calculator. And I come up with 16.04. There's a 2 at the end. Now that I have moles of CH4, I can use my mole ratio. Since I have CH4 on the top, I know I'm going to put CH4 on the bottom. In my balanced equation, there's just one of those. Now, I have to decide here what I'm going to put on the top. Am I looking at the 4 hydrogen or am I looking at the 1 carbon dioxide? To help me with that, I just need to go down here where it talks about theoretical yield. It asks me to find hydrogen, so that means I want to use hydrogen in my problem here. So I can pull the 4 from the balanced equation, and now I'm ready to multiply and divide. I'm going to do the same steps for the second part. If I have grams of H2O on the top, I'm going to put grams of H2O on the bottom. And I know that's always equal to 1 mole because this is molar mass. I'll add up my numbers from the periodic table. If H2O is on the top, H2O has to go on the bottom. And I'm just going to pull my coefficient from my balanced equation. I'm still keeping H2 at the top because remember I want to solve both of these for hydrogen. So now I'm ready to plug my numbers in. I'm going to multiply the top, divide by the bottom, and I get something like 0.988 moles of H2. So this is my smallest number. So that means my limiting reactant is H2O. My excess reactant is the CH4. When I want to find theoretical yield, that just means grams. So I'm going to take my smallest number, which is the 0.988. If I have moles, I just need to convert it to grams. That's all it's asking me to do. I have moles are on the top. I know moles have to go on the bottom. I'm going to find my grams by looking at the periodic table. Since I have 2 hydrogen, H2, I have to remember to multiply that. So we come up with 2.016. Now, when I multiply that by my moles, I end up with a theoretical yield of 1.99. And that's in grams. The last part of the problem wants me to find the percent yield. And again, we just use the at formula, A over T. 0.85 grams were actually produced. So that's going to go on the top where the A is. And then my theoretical yield is the T. Well, I'll put my, don't forget you have to multiply by 100. That's how we get percent. So I get about 42.7%, which is not quite as good as what we got on the last couple of problems, but that's okay. So that is it for the notes. If you need to go back and rewatch anything or pause anything, feel free to do so. And then please ask if you have any questions.